right, folks, let's get started. This talk is about Azure Storage and how we can use AI and run your AI workloads on Azure Storage. Well, let's dive right in. My name is Vamshi Kommineni. I have Saurabh here with me, and we have a guest speaker as well coming up a little bit later in the talk. So many of you are probably familiar with Azure Storage. How many of you here use Azure Storage in some form or another? Okay, all of you. That's good. That's what I like to see. So, as you all know, we have sort of three families of storage across: block storage that attaches to VMs, file storage that you, again, attach to your applications or your VMs, and object storage. In this talk, we're really going to focus a bit more on Azure Blob storage as well as Azure Managed Lustre. And then our other talks, we'll show you a slide at the end that have covered the other services. We're also going to spend a little bit of time about maybe the last 10 minutes of the talk on the data management services. We have some really exciting stuff happening there. Azure Storage is, I kind of described it as the file system of Azure. It is the underpinning service that all of you use as one of those fundamental things when you build your Azure services. It's also the underpinning of all Microsoft services. So if you're using SharePoint, OneDrive, Teams, Xbox, you name it, you're using Azure Blob Storage usually, but Azure Storage more broadly under the covers. This is a massive service that continues to grow over time, hundreds of trillions of objects. Over 200 exabytes of data read and written each month, and over 700 million transactions a second. That's kind of a mind-boggling number. It's so large as developers and engineers, we can't even kind of start to fathom that across the regions that we run. So in this talk, we're going to kind of split this talk into a 2/3, 1/3 piece. We'll start by talking about storage for AI workloads. We'll split that and talk about storage as it relates to training and especially fine-tuning as you take foundation models and enrich them with your domain-specific data. We'll also talk about inference, which is of course sort of the bigger workload over time for all of us as enterprise developers, and as well as talking a little bit about how agents and sort of the agentic loop is changing that and how we're thinking and learning also along with you and building services and capabilities that go with that. The last third of the talk, we'll talk about AI for storage, AI capabilities that we're building into our storage services, in particular focused on intelligent data management. So that's kind of the frame of the talk. We'll come back to this frame over time. So let's start with that first topic here, which is really about AI training and fine-tuning. I'll show you the slide. It's a busy slide. I'll try to walk you through it from left to right here. And oftentimes, whether it's foundation model training from Microsoft's AI models or OpenAI, it follows roughly the same frame. And in fact, even for your fine-tuning, you'll follow often the same frame, just as a different scale point. Starts with bringing data in to the storage system. It might be terabytes. It might be hundreds of petabytes. You bring that data in. You clean that data, annotate it, add metadata to it, usually through open source Spark or Databricks, and then you transform it using CPU cores to this training data that's then loaded into the GPUs for the training runs. So at that point, if you're bringing foundation models, you're also loading the base model weights. At that point, this training process generates a lot of data. You call checkpoint data. It's sort of the state of your GPU cluster, if you will. And that, from a storage perspective, is actually one of the core challenges. You're looking for terabit scale read and write throughput. You may be generating exabytes of checkpoints that you have to retain for a very, very long time for traceability and model lineage and things like that. And when you're done training, you have to deploy that model, wherever your AI inference is happening. So when we look at the requirements across here, as I said, the scale may differ, but the requirements are very much the same, whether you're training very large parameter count models or you're fine-tuning them. You have this raw data ingestion problem. You typically clean and prep that data using an analytics engine. We have the throughput and scale issues we talked about, and then you have to also manage those models and the model versions and everything to that effect. So over the last couple of years, we've sort of adapted the services and capabilities of storage to make sure you have the right service for the right step of this workload. Whether it's bringing that data in with Storage Mover, a fully managed online data mover service. We, of course, have always had our DataBox offline import. The really tight integration of storage with Databricks and open source Spark, and the ability to work with your data with Azure Data Lake Storage. We've invested a lot in throughput and scale. We'll talk a little bit about that later in this talk. And then, things, foundational capabilities like object replication that make it easy for you to move your data around. So what's new? What's coming? What's happened in the last 6 to 12 months? Again, this is a big list. I won't go through all of it. We'll touch on a couple of things that are bolded, and we'll talk a little bit about what we've done there. But the thing that I want you to take away from this slide is, again, as we look left to right across this pipeline, we're looking at learning from our customers, learning where the gaps are, and improving and adding capabilities for us. A good example of this is Storage Mover, was originally focused on on-premise movement into the cloud, but a lot of our customers said, hey, I want to move data across clouds and I want to move it very easily. So that's something we're investing in. Or the security, constraints and requirements have really kind of gotten tighter and tighter over time. Network Security Perimeter is a service that went GA this summer that really kind of pairs well with storage as a PaaS service. We're also investing a lot in AI frameworks and building native integration like our PyTorch connector, our FSPec compatible ADLFS package, and other things. And of course, the question is, how do our customers use this? There isn't a bigger customer today in terms of AI than OpenAI. And I think that's really been one of the things that has contributed to us being able to learn and be at the forefront of this is we've been running at absolutely massive scale for the last 3 years, from the very first supercomputers we built for OpenAI to the current generation supercomputers and onwards, as well as the inference workloads. So everything that you're going to see in this talk is available publicly, but was built a few years ago in sort of blood, sweat, and tears, learning from the scale points, the scale challenges. And in the service underpinning all of OpenAI's training and inference workloads is really Azure Blob Storage, right? You get the exabytes of capacity that they need for their supercomputers off of a very standard blob storage with the REST API and everything there. And we've built capabilities like scaled accounts to really deliver incredible amounts of throughput that even for us a few years ago was a little bit science fiction. I want to show you this picture. There's a great blog post if you search for Fairwater supercomputer, a couple of blog posts over this year that talk about the scale of the AI supercomputers we've built in partnership with OpenAI as well as for Microsoft's AI efforts. That building on the right, the very long building, is a storage and compute data center. Right? The thing on the left or towards the back is the liquid-cooled GPU, the cooler building, if you will, literally and figuratively. But this building on the side, that little green box for scale is a delivery van, right? That is how big this building is. It's actually kind of hard to conceive. And this is filled with thousands and thousands of racks of storage, exabytes of capacity, and we have N of these supercomputers going up across the United States to serve those training and inference needs. And again, blob storage is standard blob storage is what's in there in those running on those servers. So let's dive into a couple of the features that are really at underpinning of this. The first and big thing is scaled accounts. So scaled accounts are what sort of kicks in underneath the covers when you take a regular blob storage account and throw the kitchen sink at it in terms of scale and throughput. Right? We detect this automatically. We take your storage account, we scale it out across an entire region, not just a cluster of hardware. We start to kind of distribute your data, distribute your ingestion, distribute your egress across the entire region. So we're really limited only by the scale of that region, and we're constantly adding megawatts and being able to expand that scale. So that is something that you get without really doing anything. It's just create your storage account, keep going. And that has been a very, very foundational element. Obviously, a lot of hard work behind that, but it is completely transparent to all of you as customers, and you get that out of the box. The other element that you can choose to take a dependency on and use for your AI workloads is Blob Fuse. It's really about the ability to mount as a storage mount point on your containers or your VMs, object storage with whatever scale it's running at, and have your code, your training code or whatever else you have, really just treat object storage like a file system, right? And we do a lot of interesting and intelligent streaming for that. You can either like do file level preloading and things like that for training data, or for these checkpoints that we just talked about, you can do using the local NVMe for either read caching on streaming when on reload of those checkpoints, or write back caching for pushing those checkpoints out, so you don't block the GPUs for too long. You leverage the NVMe right there, and then you exit quickly for the GPUs to continue. So this has been another very foundational investment that really pays dividends. This one you do kind of have to do a little bit of configuration, but again, we've tried to make it very, very simple to use with default configs and things like that. So these things, when you put them to the test, how does it net out? So in preparation for this conference, we took a benchmark we had run a couple of times for other conferences. We said, how much further can we push this? For reference, at Build, we showed this running at 25 terabits of read and about 12, 15 terabits of write. Right? That's already a big number, and we said at the time we're really limited by the number of cores we can, gather together to go stress the storage system. This time, with a lot of like nighttime testing and whatnot, it helps to have colleagues in Europe. We were able to scrounge up about 100,000 cores and go run a test, and here's the results. So what you're seeing here is a write benchmark going up to 22 terabits per second, and a read benchmark going up to 50 terabits per second. Again, standard blob storage account, we just wrote 1.5 petabytes of working data into it, and we're running a benchmark on top of it. It isn't even a particularly special region or anything, it's just one of the regions in the US that happened to have enough cores free for us to go do a spot core run on there. So this is something that we're incredibly proud of, and you're able to use it for all of your storage needs. You generate all that data, you're going to have a challenge with cost, right? You're going to start looking at, well, how much work do I have to do to manage this data? One thing we're very pleased to announce in preview at this conference is what we call smart tiering. So we've always had tiers, hot, cool, cold, archive for offline storage. And what we haven't had those, we've always said you can lifecycle manage it. What we haven't had before is, hey, can I just have you guys do this for us? And that's what smart tier is. You set the flag on the account and say, I want this whole account to be a smart tiered account. And we look at your data access patterns. We've had this like little flag built into our service for 3 or 4 years now called last access time. So about once a day as reads happen, we essentially track last access day. So using that, we're able to tier your data down. If your data has not been accessed in 30 days, we move it to cool. If it's not been accessed in 90 days, we move it to cold. And the real kicker here is we don't charge you for read access from those tiers. So that's the big difference between hot, cool, cold, you managing it yourself. We said, hey, because we know and we are controlling when we move the data down, we will not charge you for data access. We'll actually just auto tier that data back up to hot if it starts getting access. So you will be charged only for that monitoring fee for us to move data on. It's a pretty nominal monitoring fee. And you don't have to deal anymore with, well, if this data is cold and I end up reading terabytes or petabytes of data, am I going to get a giant bill for read access that I would have in the former world? So this service is in preview now. We'd love for you to try it out. We're working hard to get this into GA as fast as possible. Switching gears a bit, we also want to talk about managed Lustre. So managed Lustre, as the name implies, is a fully managed Lustre service. So if you need very, very high throughput, even more throughput on a very small amount of data, which is a not uncommon scenario for fine tuning, this is another option for our customers to use. And you can keep your larger data sets in Blob auto import that data into managed Lustre, and then attach, through a Lustre client, attach that data to your GPU clusters. There's some really great improvements coming in this as well. It's been GA for a couple of years. The biggest thing is a continued growth in the namespace, 25 petabytes, 4 terabits of throughput, that auto import capabilities that we talked about. And really, this is another capability that we see our customers using when they're doing either training or inference in some cases. So again, proof here is really when our customers use these capabilities that we build. And we're very pleased to have here Natalie Mao, who's a VP of AI and Data at the Rakuten Group. They have been leveraging our system to do their AI transformation. So Natalie, I'd love to have you come up and talk about your experience with us. Thank you.
Thank you, Vamshi. Thank you for having me here. It's my pleasure to share how Rakuten uses Microsoft Azure Storage for our large language model development. For those of you who do not know Rakuten, we are an AI-first leading Japanese company with more than 70 business services in diverse industries such as finance service, telecommunication, and e-commerce. We have more than 900,000 business partners and serve more than 2 billion members worldwide. Our 30,000 employees are geo-distributed across 30 countries and regions. Here are some examples of our business services, such as e-commerce, credit card, and online travel that are ranked as #1 in Japan. Outside Japan, we also have leading global businesses, such as Rakuten Rewards, Rakuten Symphony, Rakuten Viber, and Rakuten Kobo. We operate those businesses in the Americas, Europe, and Asia. To drive the AI transformation for our more than 70 business services, Rakuten has heavily invested in AI, including building our own Japanese large language models for the Japan market. Here are just some examples for large language models and small language models we have launched last year. Currently, we're working on large language models with hundreds of billions parameters. To develop large language models at this scale, we must have secure, high throughput, cost-efficient, and scalable storage solutions. For that, we currently use Azure Storage. As you can see from this high-level architecture diagram, we have 2 tech stacks, one for training and one for inference. For training, we train our large language models over thousands of GPUs and store checkpoint backup into Azure Blob. Our distributed training framework reads petabytes of training datasets directly from the Azure Blob storage with blob-aware I/O optimization. With this solution, we reduce the storage cost of datasets by 70% while maintaining high data throughput to prevent training bottlenecks. We leverage Azure's high performance managed elastic clustering for synchronous model checkpointing and loading. This gives us ultra-low latency and reduces the checkpointing time by more than 80%. This solution helped us to speed up the overall training by 20%. By using Azure Storage across Azure Blob and Azure Managed Elastic, we simplified our management of our vast datasets and model artifacts through the integrated data storage solution. This has been a reliable, scalable, and cost-efficient data storage solution for us so far. As the next step, we will continue inference efficiency optimization to further improve throughput measured by tokens per second and reduce latency measured by time to first token for our in-house LM models. In addition, to further improve inference throughput, we are exploring Azure's advanced storage solutions to implement multi-layer caching strategies. with advanced storage solutions like Microsoft Azure. We are excited to provide more AI innovation to our customers and partners. Please feel free to reach out if you have any questions. Thank you.
Thank you, Natalie. It's great to see our customers are really using this in production and kind of getting the results that they need. One of the things that Natalie talked about here, as you can see, is inference acceleration. And I think that's increasingly going to be something that we're seeing is there's kind of settling down to be a few big foundation model players. You'll fine-tune your data you'll use your data to fine-tune these models, and you'll run inference against those models, those fine-tuned models. So one of the ways to think about this, and we'll use a little bit of a diagram to build this up and then talk about some of the features we're adding there. Of course, at the bottom layer, you have physical infra with your GPUs, your network, and a bunch of local NVMe usually. You either have VMs or Kubernetes pods running on top of that hardware and virtualizing that. Your local NVMe typically is also virtualized. So you have a few options here putting all of this together. You can have something like BlobFuse 2, using that local NVMe for caching and talking to remote Azure Blob storage. You can also have custom-built connectors for AI frameworks like the ADLFS or PyTorch connector. We talked about Azure Managed Lustre and having more full-fledged POSIX functionality and being able to work with your remote storage that way. We also have Azure Container Storage, which is an interesting way of sort of bringing all these different storage services together and providing an abstraction for your Kubernetes cluster. So again, if you look at training and inferencing, it's increasingly on the compute side, wrapped and managed by Kubernetes. So we have had this feature, this capabilities with Azure Container Storage in GA for a little while, and we're increasingly stitching that story together with AI going forward. There's a compute orchestration, of course, we talked about VM scale sets on the VM side, AKS on the Azure Kubernetes Service on the Kubernetes side. And then you can have a runtime like Ray or PyTorch on top of that for your training and fine-tuning. And the Kaito, which is, if you're familiar with it, is on the Microsoft side for inference using open source models. So that's kind of a end-to-end picture, wrapping up this AI training and also starting to look into inference. So I want to dive a little bit deeper into container storage. For that, I'll hand off to Saurabh, and he'll walk you through a little bit more of this.
Thank you, Vamshi. Kaito is Kubernetes AI toolchain operator. It's a Microsoft solution built on top of AKS to essentially simplify how you provision GPU clusters and how you connect those clusters with your data, with your models, and inference with them. And Azure Container Storage, as you can see in this picture, plays a key role in terms of enabling a persistent volume on each of those Kubernetes pods and connecting those volumes with range of backing storage options. So today, we support with local NVMe. And that allows you to get extremely fast performance. And now, with a new version that we have available, you actually get 7x more throughput and 4x less latency by using all the performance that is natively available on the NVMe. So think about this is really powerful because what this allows you to do is to cut through all the hoops between your GPU clusters and your remote storage systems by basically presenting the local NVMe as a persistent volume. So now you can run kubectl commands against that volume as though it was basically locally attached to your Kubernetes clusters. And that's really powerful. And so what we're going to do here is to see a bit of a demo which essentially shows this in action. And in a sense, what we have is we have a couple of nodes that essentially are interacting with the local NVMEs attached to those nodes through Azure Container Storage clients, which present them as persistent volumes. So let's see this in action. I'll switch to the demo machine. Hopefully this works. OK, so we're going to run kubectl with loading a model, a 𝗦𝗲𝗀𝗀𝗀 3.3. It's about 33 gigs in size. And we are loading it without any kind of orchestration with Azure Container Storage. And it takes about 600 seconds to get there. And then when we essentially try this out with Azure Container Storage, We start with the Kaito configuration file. So we look at the Kaito configuration file. And so that is, we're going to load the configuration file. And this is where you see how we are configuring Kaito itself. Now, the best part is Azure Container Storage is abstracted completely by Kaito. So once we set up Kaito and run it with Azure Container Storage, that model loading time drops by 2.5x. And so you're now able to load a 32 gigabytes model. And if you extend that beyond, you essentially can run inference at a very fast pace. And that's what you're seeing here. We're essentially able to run a query leveraging the model load from the local NVMe through Azure Container Storage and able to run this inference successfully. So what we essentially did here is to be able to get to a point where we have almost 5.6 times faster performance compared to loading things from the local NVMe directly versus having container storage, which abstracts your local NVMe as persistent volumes. And this is something that gets even better for larger models, which otherwise don't even fit that NVMe storage. So we're talking about models which are probably hundreds of gigabytes in size. And that is exactly where you get this kind of acceleration leveraging Azure Container Storage. It's available today, so please try it out. And the best part is with Kaito, you don't even have to set it up because Kaito abstracts the entire thing for you. All right, let's go to the next section, which is the inference section with storage. And that is where we're going to look at a similar diagram as to what Vamshi was showing earlier with regards to training. But it's only the first portion which is similar, which is where you bring in the data. How many of you are familiar with Retrieval Augmented Generation, or RAG? Show of hands? OK, quite a few people. So generally, what you're doing with Retrieval Augmented Generation is you're attaching your own enterprise data and context to these models. And the way you do that is you have to obviously process the data, clean it, make sure PII is removed, and then you chunk it down to logical fragments so that you're only retrieving the fragments that are relevant to your query, right? And then you load these fragments into a vector database by converting them into embeddings. And that allows you to essentially perform a vector similarity search when a query comes in. And so the query gets converted to a vector. We perform a vector similarity search, which is essentially a semantic search. And that tells the model what fragments it should retrieve for prompt augmentation and finally a response. Important point to note here is you do want your latency from storage when you're retrieving that data to be extremely low so that your users are not waiting for that data, right? And now with agentic systems, you have this notion of feeding the response back into the LLM and using the vector database time and again in a single agent loop. So you're retrieving much more, but also as a response, your agent is generating data, and that is getting stored in storage as well. So that essentially creates requirements for you to not just manage your data and how it gets to these models, but also how you manage the AI data that is generated. Most importantly, you want this data to be securely retrieved. You don't want any kind of exfiltration to happen. And also, you want to achieve freshness so that the latest data is what you're getting through all of that steps in the pipeline. Two things to note here. One, your data as it is today, your primary data, is not how your LLM uses it. There are multiple representations that get created. There is chunks, there is metadata, there is vectors that get created, and it's up to you to manage all of that. And so we have a bunch of capabilities today that you can use that allows you to achieve these objectives across the notion of bringing enterprise data to AI, and then ensuring that you securely retrieve and manage the agent-generated data as well. So on your left, there are capabilities, some of which also, by the way, overlap a lot with training when it comes to data prep with Azure Databricks or OSS Spark. But on the right side, you see Premium Blob. Premium Blob is something that allows you to achieve consistent low latency. And through our benchmarks, we've seen almost 3x to 5x faster retrieval performance to keep that latency budget really low and make sure your inference happens much faster. The other thing that we have, which we'll talk about in detail, is great security with Entra ID and network security perimeter. And there is a whole set of capabilities that we have announced this time at Ignite, where we integrate deeply with AI services across AI Foundry, AI Search, and of course, ensuring all of these things can get integrated into agents that you build with both first-party Azure services and third-party OSS services as well. So let's dive in a bit into security, and let's look at what we have across data and network security. So when it comes to data security, a lot of people think about the fact that it's only Entra ID, but not really. There are multiple layers that ensure that your data adheres to zero trust standards, and that extends over to even agentic applications. So there is a lot of talk about AI, but the good old infrastructure service that we have in storage already has these capabilities that you can extend into your AI workloads. So you start with your identity with Entra ID, and then you essentially use your role to check against a policy which is telling you across your environment, across your data estate, what are the kind of tags that you should be looking at? Is it a single department or something else that you should be looking at to be able to get access to that data? So we call this ABAC, or basically essentially attribute-based access control, which checks these attributes against your data. And then if you want further granular access, you essentially go to ACLs, right, or access control lists, and that gives you the security down to the file folder level. And then finally, when that works, you get access to your data. So all these layers are essentially something that you can configure. And the best part is, for the integrations that we have with AI services, you don't even need to worry about that, because all of that great integration with AI services works with all these layers of security. On the network security side, we have network security perimeter that went generally available about 6 months back. And what that allows you to do is to essentially ensure that you can house all your AI services along with your storage in the same network security group, and ensure only authorized IPs can access your data, both on the inbound side and on the outbound side. Right? So that allows you to prevent data exfiltration. It ensures you have centralized network isolation, and you're not essentially configuring a bunch of things at different places. And more importantly, it gives you secure service-to-service communication, which we'll see in a bit how it works with AI Search, AI Foundry, and all the AI services we have. All right, let's dive into a quick demo. I'm going to pace through this a bit because we are running out of time. All right. All right, so what you're looking at here is called Storage Center. If you go to the Azure portal today, go to the search bar, look for Storage Center, you'll find it. And this is the one place where you can find all your Azure storage services across your entire data estate. So you can see storage accounts, disks, Elastic SAN, and everything. And not just that, you can also discover services by clicking into these settings or these menus that you have on the left. And so I can go into blob storage from here. I can go into block storage. In fact, I can also access some of the partner solutions that we have across Azure Storage. So what we're going to do here is to go into blob storage. And if I click on resources, I can go into a resource that I have today, which I'm going to use to see our integration with AI services. This is my storage account. And so you can see how I can go to my storage account directly from Storage Center. But wouldn't it be nice if you were able to connect this data to AI services right where your data is? And so today we are excited to sort of preview to you in an experimental research that we are working on, or experimental preview we're working on, called Storage for AI. So you can actually kickstart your AI journey right from your Storage Center with the Storage for AI experience and build applications that leverage your data. So let's look at this. When I click select, we see the same flow that we saw when you bring your data into your inference pipeline across migration, data preparation, and fine-tuning. And here you can discover all the Azure AI services that work directly with your data on blob storage. Right? So this is great. We are going to go to AI Foundry right from here. And as you can see, I was able to go into AI Foundry, and now it has all the context of my data that I was using. Of course, AI Foundry has had a facelift this Ignite, so let's click into the new Foundry experience. And out here, I can build agents. But what I'm going to show you is how you attach your knowledge context or your data as knowledge to your agent. So I click on knowledge. I create a new knowledge base. And right here, I see Azure Blob Storage. So the same account that I essentially picked, I can select that same account here. Just like that. And as I hit create, it essentially starts indexing, chunking, enriching, and finally converting all of that data into a knowledge base. So it's as simple as that. I already have created a knowledge base here. You can see it right here. And this is, again, an Azure Blob Storage type knowledge base. I can also create a new one and augment my knowledge base directly from this place as well. So now let's do something fun. Let's connect this to our agent right here. And click save. And what I have is a knowledge base which has the content for all my Ignite sessions. So I'm going to say, what are the performance characteristics, or rather, what is the performance of UltraDisk? Let's see. OK? What it's doing now, it's essentially calling my knowledge base as an MCP server tool. I approve it. And just like that, I get the performance characteristics of UltraDisks. And the best part is it essentially sourcing it from all the docs that I've essentially provided in my knowledge base. So it's as easy as that. And so with that, I'll just go back to our main screen. And we saw that essentially you can integrate Azure services or Azure storage very easily with AI services. You can do that with AI Foundry. You can do that with AI Search. You can, in fact, even do that with Azure Machine Learning if you want. But most importantly, not only can you bring your data to these services, you can also configure storage to store the agent data that these services spit out. So we essentially have AI Foundry standard setup that went GA recently. And now you can bring your Azure Blob Storage accounts to AI Foundry for storing your agent outputs as well, in addition to bringing your data. We also just saw Knowledge Base, which is working with Foundry IQ, which is in preview. And by the way, if you are not using AI Foundry and you're using third-party tools or OSS frameworks to build your agents, what do you do then? How many of you here use LangChain or know about LangChain? OK, quite a few hands. We have some good news coming up for you, and so we'll see what essentially happens. But before that, I wanted to essentially give you an opportunity to be a part of our research, which we are doing with Storage Center for AI. And so we would love to have you participate in the research study and help us shape how we can make it easy for you to bring your data to these AI services right from Azure Storage. So please scan this QR code and reach out to us. Meanwhile, let's quickly switch to our demo machine here again. And let's look at LangChain. OK, hopefully the font is visible. If you have used LangChain before, how you would essentially bring data from blob storage into LangChain is to essentially use a file loader or a container loader. But in the process, you had to provide an account key, not the most secure thing to do. So what we did is we essentially officially started supporting LangChain by converting this to a native blob storage loader where you don't have to provide your account key. You essentially use your default Azure credentials or your managed identity or your SaaS, if you will, to provide much more granular access. That's number one. Number two, you would earlier have to just use a loader that LangChain provides. You could not have your own loader to extract and enrich the data. Now you can write your own loaders and essentially provide that as part of the loader factory right here. Number three, what we are doing is we are not loading all the documents. So imagine you have millions of documents into the memory. And that's really, really powerful because with lazy load, that is something that we introduced, we can streamline how much memory gets consumed while the agent is running. So now you're not going to see the crazy amount of multiple hundreds of kilobytes or multiple tens of megabytes of memory usage when you have large number of files. And that gives you much better performance as well. And finally, this entire thing integrates seamlessly with AI services as well. I'll show you what kind of performance characteristics we are able to see. If you notice here, lazy load essentially gets you more than 5 to 6x worth of time savings. And for larger files, you get almost 10x worth of memory savings with the new loader. So this is something that can take your applications from pilot to production very, very quickly with LangChain. With that, I think we'll switch over to the last segment, which is intelligent data management. We just saw what we have with our OSS services. And over to Vamshi.
Yeah. Thank you, Saurabh. This is a great overview of sort of inference and probably the more topical thing for all of you in the room. So let's close out. We have a few minutes. We'll try to rush through this as fast as we can, talking about AI for storage. What are we doing in the areas of intelligent data management? As you have more and more data, one of the things that happens is you have N regions. You bring your data into N Azure regions because of data residency and compliance. You have workloads. Those workloads have storage accounts, and those storage accounts have lots of blobs in them. So you end up with this huge sprawling data estate. It's a real problem for a lot of our customers today. And you really want to be able to move that data into Azure, but you also want to be able to analyze and really manage costs and understand your data estate. And then you want to be able to act on that data estate. You want to be able to take actions to help manage the cost or take some other security or other configuration actions. And our kind of point of view here is storage can and should reduce that operational burden for you with an AI-first approach. So what have we done here? We have had Mover here for a couple of years now. We're adding capabilities to that. For the first time this year in August, we GA'd Azure Storage Discovery. And we've also GA'd Azure Storage Actions earlier this year. So this is the first time we have services across these pillars of move, analyze, and act. And we'll continue to iterate and improve on these services. So we'd love to show you quickly just Storage Discovery here, because it's a pretty nifty thing. And as that's coming up, what I want to show you here is this is a discovery workspace. You can go create one of these for your data estate, depending on your read privileges across your company. One thing I want to help clarify for you, this is a real customer. It's an internal customer. It's all contosified and PII removed. But this is a real internal customer with 1.2 exabytes of data and 56,000 storage accounts across many, many regions. And as you can see here, 283 billion blobs. This is something you weren't able to do, is just kind of very quickly go across these things. So you can see in terms of regions, the biggest region is Europe North, right? You can start to look at what are my top accounts, and you can see there's an account with 745 petabytes of data in a single account. And have that visibility. You can also see where my data is distributed across regions. You can see that there's that Europe North with 1.1 exabytes. But interestingly enough, you can kind of go down and say, well, what about blob count, right? And you can see there's other regions like US West that have a lot more blobs. Again, running at scale across hundreds of billions of blobs. You can kind of go in to not just capacity, but you can look at your transactions, right? You can look at activity across how many billions of transactions, how much data am I reading and writing? Again, this is just over the last 7 days, right? This is, again, a real set of data running across. You can go down and analyze and see what's happening with similar set of views. You can look at your error data, right? You can look at what kinds of errors am I having. Client other errors are, kind of what happens on the client side. You can look at your throttling errors at the service side, authentication or authorization errors. Again, look at the number of transactions there over that period of time, nearly 500 billion transactions. Again, single pane of glass, you can check your configuration for all those 56,000 accounts and start to drill into them and say, hey, where do I have change feed enabled? Or where do I have, what kind of redundancy does this thing have? More interestingly and importantly, perhaps, you can start to check the security posture of those accounts. Is there anonymous access enabled on any of those blobs, which is a pretty big problem unless you know you really aren't enabling it for good reason. Do I have shared key access, or am I moving away from it? So we've tried to make this somewhat really easy to navigate and use, but we also have been building a Copilot experience. In the interest of time, I'm going to run through this in a recorded video form. And let's kind of go down there and click play here. if you go into the Copilot experience there, you can really start asking the data model behind all of this data questions. Like here the question is, what storage accounts have the least transactions? So I can start to look at tiering that data down, and you get straight away a set of accounts that you can take action on. Again, a subset against that 56,000 accounts, and you can kind of look and see and say, okay, maybe I want to do something with these things. You can then go in and start to ask things like, show me the distribution for security access, right? Which ones have shared key access? So this will give you that view and be able to really tell you very quickly about things that are enabled or disabled. You can also start to say things like, give me a way to go take action on these things. So let's say I want to use a script quickly to kind of go disable shared key access on a bunch of accounts. I can ask Copilot, write me a script to go disable shared key access. It'll go look at this thing, kind of find you the AZCLI commands that you need, and you can go execute those things. So we'll continue building on this capability set and kind of going forward from there. So we're almost at the end of our talk. I know we're starting to go a little over. We'll have time for Q&A at the end. We'll stick around. But what you saw here was kind of a set of capabilities across Mover, Discovery, and Actions. And just in terms of wrapping up the talk here, we showed you how you can have fast and scalable storage for your training and fine-tuning. We talked a little bit more about security, which is really important in inference scenarios. And we talked about this intelligent data management aspects. I'm going to leave you with a bit of an eye chart here. Well, this will be in the slides you can download. But for all of the things that we've added and talked about in concepts, we've built a set of resource links for you with samples and other things that you can go try. Previews you can go sample after the conference. So we'll leave this up here for you. There's one more storage talk coming up tomorrow. So if you're still around, please come look at this. That dives more into block storage rather than blob storage. And last thing I'll leave you with, we'd love to have you take a short survey. It's a 2-minute survey. If you can snap a picture of this and fill it out later, we'd appreciate it. Again, thank you for taking the time. Thanks for coming to this talk. Appreciate it.